Section 4.3 is about factoring a number. We kind of already did factor trees, but it's also about finding the greatest common factor. So list all the factors of the following numbers. So if you make a rainbow, 1 and 2 are the only two factors. In 3, it's just 1 and 3. In 4, it's 1 and 2 and 4. 5 is 1 and 5. 6 is 1 and 2 and 3 and 6. 7 is 1 and 7. 8, 1, 2, 4, and 8. 9 is 1, 3, and 9. 10 is 1 and 10, and 2, and 5. Oops, I almost forgot the other ones. And 11 is 1 and 11. Now put these numbers into two different categories. Numbers whose factors are 1 in itself. So which ones only have 1 in itself? 2, 3, 5, 7, and 11. So I'm going to write down 2, 3, 5, 7, and 11. Now what are numbers that have more than two factors? 4, 6, 8, 9, and 10. Numbers whose factors are 1 in itself are called prime, and numbers who have more than two factors are called composite. So a prime number only has factors of 1 and itself. Composite numbers have factors of more than 1 and itself. So down here, which of the following numbers are prime or composite? So if I make a factor tree, 1, 2 doesn't go into 23, 3 doesn't go into 23, 4, no, 5, no, 6, no, 7, no, 8, 9, 10, 11, 12, no. So it's just 1 and 23. So that means that this number is prime. Now I do 45. 1 and 45. 2, no. 3 goes into 45 plus 4 plus 5 is 9, and that's divisible. So 3 matches up with 15. 5 matches up with 9. So this has more than a factor besides 1 in itself. So it's composite. Which numbers from 12 through 20 are prime? 13 is prime, 17, and 19. The composite ones are 12, 14, 15, 16, 18, and 20. The prime factorization is when you factor a number into all primes. So how you do that is think of a number that goes in, think of two numbers that go into 72, that when you multiply them you get 72. Well, I can get 2 and 36, 2 times 36. So now what I'm going to do is I'm going to circle the prime number that's at the end of my root. I call these the roots. And I can keep going with 6. 6 is 2 times 18. And I'm going to circle the prime number. 18 is 6 times 3. And I'm going to circle the prime number. And then 6 is 2 times 3. And these are all primes. So at the bottom they should all be prime. So I'm going to write all of the primes. 1, 2, 3. I have 3 2s, so I'm going to write this as 2 to the third times 3 squared. That's the prime factorization. So then I do 225. So I can't divide it by 2. I can divide it by 15. So 15 is 3 times 5. So I circle my primes. And 15 is 3 times 5 over here. So then I write the least number first is 3. And there's 2 of them. And then 5, and there's 2 of them. So it's 3 squared, 5 squared. Alright, and to make the prime factorization of 236, I'm going to divide it by 2, because I know it's divisible by 2 because it's an even number. So 236 divided by 2 is 118. I'm going to divide 118 by 2, and I get 59. And 59 doesn't break down any further. So it's 2 squared times 59. And if I do a factor tree by 121, I know that 121 is not divisible by 2 because it's not even. And I can check to see if it's divisible by 3, but 1 plus 2 plus 1 is 5, and 5 is not divisible by 3. So it's not going to be divisible by any even number, so then I check 5, no, it doesn't end in a 5 or a 0. 7, no. 9, no, because it's not divisible by 3. 10, no. 11. 121 is 11 times 11. So this is going to be 11 squared. That's the prime factorization. So common factors are two numbers that are factors in both. And I guess they don't always have to be numbers either. The greatest common factor is the highest number. So the best way to do it is to practice this. So example, find the greatest common factor for each pairs of expressions. So what you do is you list out the factors of 9, which are 1, 3, and 9. You do the rainbow tree. Factors of 21 are 1, 3, 7, and 21. Now you look at which is the greatest number that's in common with both. So go from left to right here. So 21 and 9, nope, they both don't have a 21 and a 9. They both don't have a 7, but they both have a 3, and that's the highest one. Okay, then greatest common factors of 40 and 60. This should actually say 40 right here. So let's do a rainbow tree with 40. 1 and 40. 2 goes with 20. 3, no. 4, yes. 4 goes with 10. 5 goes with 8. And that's it. So 5 and 8. Then do the same thing with 60. So 1 goes with 60. 2 goes with 30. 3 goes with 20. 4 goes with 15. 5 goes with 12, and 6 goes with 10. So working from the left, which one is the highest common factor, greatest common factor? So they both don't have 40 and 60. It's 20. 20 is the greatest common factor. Sometimes you can have variables. So I'm not going to look. There are tons of factors of 6a cubed b. There's 2ab, 2a squared b, a whole bunch of factors. So I'm going to go right down to the greatest common factor. It's going to be faster. So what you do is you look at the factors of 6 and 4. So 6 has 1, 2, 3, and 6. 4 has 1, 2, and 4. So the greatest common factor of 6 and 4 is 2. Now when you look at the variables, they have to have the same variable, which they both have a. So you're going to take the lower exponent of the two. And then you look at the b's, b and b. So that's just going to be a b. So down here we're going to do some more examples. So 8 and 20. 8 and 20. So first find the factors of 8. 1, 2, 4, and 8. Then do the factor tree for 20. Now go from left to right. What is the highest number they have in common? Ooh, I missed one for 20. It's 4. There we go. So the highest number, the greatest number they have in common is a 4. Now let's do 12 and 87. So 1, 2, 3, 4, 6, 12. 87 is 1, and I know it's not divisible by 2 because it's not even. Now let's try 3. 7 plus 8 is 15, and that's divisible by 3. So if I do 87 divided by 3, I get 29. Okay, then 4, no, 5, 6, 7, 8, 9, 10. Actually, that's it. So the greatest common factor is the highest number is 3. And then if you have, this one has variables. So you take the greatest common factor of 15 and 45. So 15 is 1 and 15, 3 and 5. 45 is 1, 3, 5, 9, and 15. So the greatest common factor is 15. Now we have to look at the variables. So if I look at the m's, they both have m's, so I take the lower exponent, which is m. And then I'm looking at their n's, they don't both have n, so it's not in common, so the answer is 15m. Common means same. And since they both don't have an n, it can't be a common factor.